Hello, I'm Matt Sherman. I'm the Digital Curation Librarian and co-chair of the Scholarly Communications Working Group here at Drexel University Libraries. Welcome to another Open Access Week talk hosted by the libraries. Open Access Week is a global event promoting the access to knowledge, highlighting open activities, and promoting actions that will make more scholarly and educational materials freely available to teachers, learners, researchers, and the public. Today, we welcome Bahrad Sokhansanj to speak to us. Bahrad is an assistant research professor here at Drexel University in the Ecological and Evolutionary Signal Processing and Informatics Laboratory. He received his Bachelor of Science in Engineering Physics from the University of Saskatchewan and a Doctor of Philosophy in Engineering and Applied Science from the University of California, Davis. As well as this research and construction experience that he's had, Bahrad also has received a Juris Doctorate from Columbia Law School and has experience clerking for the U.S. Court of Appeals of the Federal Circuit, and has a fair amount of, and is currently retaining experience and working as a lawyer litigating patent and trade secret cases. He is currently pursuing research in cutting-edge machine learning methods with applications to genomics and law. Bahrad's presentation today is entitled Predicting the Outcome of Legal Proceedings Using Deep Learning. He will speak to us for about 20 minutes, followed by 10 minutes for questions. Please send your questions privately to me in the chat during the presentation, and as time permits, we'll allow additional questions afterwards. Without further introduction, Bahrad Sokhansanj. Your mic, Bahrad.
I just realized I was muted. So what I said was thank you for coming. Like I said, let the host know if you have any questions as I go through. I'm not really sure in this talk how much to calibrate, sort of the background on the computational side versus the legal side, but we'll kind of see as we move along. I gave this a very broad and ambitious title, Predicting the Outcome of Legal Proceedings. Obviously, that's sort of the gold star, the challenge. What we did was do something on a somewhat narrower question. And so this is the paper that was actually supported by Drexel's open access funds, which I think is a really exciting and useful program, really key towards the future of publishing and for projects like this, for a reason I'll discuss at the very end. But what we did here, as the title of the paper indicates, is look at a specific kind of legal proceeding and try to see if we could use deep learning to try to analyze what the participants in this legal proceeding are submitting, try to see how successful their arguments are, and ultimately see if we could use these deep learning computational techniques to predict the outcome of those proceedings, but more importantly, also kind of interpret and understand those models that we learn in order to try to appreciate, what are some good arguments that were used, what are some good techniques and tactics that participants use, because that's really ultimately what is important when it comes to legal practice. So the whole, you all are familiar with this idea of an AI revolution, certainly a lot of you, an AI revolution in how we understand biology. Those of you who come from libraries, AI is changing everything in terms of library practice. It's also obviously a huge deal in legal practice. And if you think about it, that makes sense because law involves text, which is something tangible that you can analyze using a computer. And it's based on formal reasoning. I mean, it's not as formal as like a computer program or computer code, but there are rules, there are systems of reasoning and logic that is something that a computer could potentially, you imagine, understand. And also it can involve a huge amount of what a scientist would call data and a lawyer would call documents. You've all heard of these cases like the, Twitter acquisition case that involved like millions of text messages and email messages and having to go through these documents. And that's just in a case that's in court. I mean, even before that, there's a lot of fact investigations and things like that that involve huge amounts of documents. And often the tasks that are involved in law are actually really repetitive. Even though lawyers, you stereotypically get paid a lot to do their work, a lot of what they're doing is actually not, different every time, and it doesn't require a huge amount of skill. It's really just a repetitive rote task. It's like, was this email written between a lawyer and a client? Therefore, it is a privileged email that I don't produce. That's a really mechanical process. I mean, that can be as simple as just seeing who's on the to from line of an email, right? So, why not automate that task rather than paying someone, $40 an hour to do it? So that's kind of the equation that a lot of people try to solve. And so the idea here is that AI is really important, is becoming really important in law for a number of different problems. And you're going to hear people referring to this using different terms. You've probably heard of artificial intelligence. That's sort of a catch-all for everything a computer does that kind of looks like what a person does when they're thinking. And then you hear the term machine learning, you'll hear the term deep learning, you'll hear the name natural language processing. All of these are often used kind of, sort of analogously, even though they might mean something different to a technical practitioner. I don't want to really belabor the background here. For a lot of the people, this is something but for many people, you don't. You've probably heard of machine learning, but you don't know really what machine learning kind of is. Machine learning, in a really simple sense, is about classifying data. Classification means something very specific to someone who does machine learning, but to you who are not a machine learning person, you can just think of everything in machine learning as a form of classification. So in this example, you have diamonds and you have stars, and you're trying to decide, oh, I have a heart suddenly appear in the middle of it. Is it a diamond? Is it a star? And I'm going to try to train a computer to try to figure out, well, maybe it's closer to the star category. Maybe it's closer to the diamond category. That's, a big part of machine learning. Similarly, and this is, again, can be considered a form of classification, or you can consider it decision-making. You can think of machine learning in terms of like, I'm trying to teach a computer to think, in this case, about like, if I observe that it's overcast, does that mean it's, raining or not, or whatever? So that's kind of another type of thinking about machine learning. And then you hear the term deep learning. And what we're doing in this paper is both machine learning more generally, as well as this concept of deep learning. And deep learning is sophisticated computationally, but conceptually just means that in machine learning, I sit there and I look at a problem and I say, okay, I'm trying to figure out what kind of a movie somebody wants to watch on Netflix. So I'm going to go back and I'm going to see, do they like action movies? Do they like long movies? Do they like short movies? Do they like movies that are in color or movies that are in black and white? Those are all features. Those are all features of a movie. And I can sit there as somebody working at Netflix and think about all of the different kinds of features. And then I can create a model and I can train it by saying, oh, I look at this person over here. They like black and white action movies that are over 90 minutes long. Therefore, they will like this kind of movie. And I'll look at another person and they like movies that are 3 hours long and are in color and are dramas. And they'll like this kind of movie. And I'll create that model. And that's like machine learning. In deep learning, rather than sitting there and thinking about what the features are, I just give it just give it the movie. I don't say what the movie actually is. And I just look at all of the different movies that people have watched, and the computer itself learns what are the important features. So the computer, through its algorithm, will figure out, oh, the things that people are taking from movies are like their length. So I'm not telling it that length is important. The computer itself is learning that the length of the movie is important. And that's deep learning. And that's like what's really driven the last 5-10 years of advancement in AI, whether it's in computer vision, where you can recognize the faces of people walking down the street, or whether it's these text models where people have like chatbots, you interact with United Airlines, and you're not talking to a person, but somehow it understands the text that you're telling it. So that's kind of deep learning. But the problem really comes is that if you look at this kind of computer model, it has all of these lines, it has all of these circles, and like you actually will see here on this slide, there's something called a hidden layer. So all of this is really just a lot of very complicated math that a computer is doing. The problem is this math is so complicated that I have no idea what's actually going on in there. It's like a complete black box. So when I create my deep learning model and it seems to work really well, I have no idea why it's working well and what its flaws might potentially be and what is it actually learning? What are the features that are important? So that brings us to the concept of interpretability. Like, I have an example here. This is a good example from like skin cancer diagnosis. And it turned out people use this deep learning model to try to predict from the slides that pathologists would look at whether someone has skin cancer or not. So the slides on the left would be like a normal skin cancer, but the slide on the right was usually what a pathologist looks at, where they put on these markers to say how large the melanoma is. It turns out that pathologists will put these little symbols on whenever they actually see a melanoma. They're not going to put it on when they see a normal sample. So when they gave all of these samples to a computer to try to predict what has skin cancer, the computer said, oh yeah, I'm like really good at predicting skin cancer. It turned out the computer was just picking up these purple spots. It was just picking up what the pathologist was labeling on the slide when they thought it was skin cancer. So it wasn't that the computer was learning from the shape of the mole whether something was a melanoma or not. It was just learning from something ad hoc, post hoc that the pathologist was adding, which wasn't really meaningful biologically. So is what you're learning real or not? For that, you need some kind of way of interpreting a model. Another thing that comes up a lot, and this is particularly important when we try to apply AI to law, is fairness and bias. So one of the applications of AI that people have been really excited about is potentially using it to make bail decisions or sentencing decisions or release decisions. And the idea people had was, oh, I can like throw in a bunch of factors and figure out whether a defendant is likelier to skip bail, whether they're likelier to commit a crime or recommit or to reoffend. And I'll assign them some kind of a risk score using a great machine learning model that I've developed, but it's this black box machine learning. I'm not going to tell you what it is. Well, people went in and analyzed what was going on with these methods, and they found that, in fact, these methods were picking up huge amounts of racial bias. So in a study in Broward County in Florida, you can see here the risk score, which gets higher as you go to the right. For Black defendants, they often were being classified as higher risk, whereas white defendants were almost invariably being classified as having very low risk to reoffend. So all of the sort of things that drive implicit bias and racism in a judge's decision as to whether to grant bail or not were simply being reapplied when you went to this artificial intelligence method from a computer that supposedly is not biased. So what we were effectively doing was teaching a computer to be biased. And we've seen this happen in mortgage decisions where computers will replicate redlining. You see this in chatbots where computers will learn how to be a Nazi. It's like you basically, a computer is just learning from what you're giving it. And so if you give it something and if it picks up features that are biased, then it will replicate that bias, even though supposedly the computer is objective. So, interpretability matters for that. And it also matters a lot in terms of actually learning from the model. One of the problems when we use deep learning is we don't actually learn about the world. We're just learning to make good predictions. But making a good prediction may or may not matter in the future. Maybe circumstances will change. What we really want to do is kind of learn something to build our body of knowledge to then be able to build better models and knowledge in the future. So interpretability is really important and a major guiding principle of everything we do in our lab, whether it's biology or law. So as I was saying, AI is revolutionizing law, and it already is doing that. People are using AI in contract preparation and analysis. One of my friends works at a firm that does NDAs for people, non-disclosure agreements, and they'll do the NDA for you pretty low cost. But as they're doing it, they're learning how a computer can do it automatically. So they're actually feeding an algorithm to learn how to do non-disclosure agreements. So in the future, if you want to do a non-disclosure agreement, the computer could just do most of it rather than having to pay a lawyer to do it. I've used it for discovery and litigation a lot. People are using it in the patent field. People use it now to do legal research. I'm not a huge fan of AI for legal research right now, but searching has gotten a lot better. And companies like Westlaw and LexisNexis use it a lot. And then another thing that we do a lot, perhaps of dubious value, is we'll try to track kind of how judges perform. So if I'm going to file a case, I'm going to file it before a specific judge on the basis of a machine learning model that says this judge is going to be better for my case than another. That's something we do a little bit. And I'm not sure how many people are actually aware that people in law do that. Or you could just be like Donald Trump and just find your favorite judge in Florida and file your cases before her. But not all of us have the luxury of appointing the judges who hear our cases. So we kind of say, okay, well, people are doing all of this stuff. What is the really big, outstanding, hard challenge? And the really hard challenge is understanding what's going on in litigation. When two parties are arguing over something like an accident, a patent case, a fraud case, something like that, where you have two sides. And what happens in those cases is the two sides will make their arguments predominantly in writing. Usually it's the writing that matters. The oral arguments are less important. The thing is, when people write in legal cases, if you have somebody doing some accident case, it's probably pretty form. Like, every case is kind of the same. They just fill in the blanks with something. If somebody is being paid millions of dollars to litigate on behalf of Apple, they're writing this like beautiful piece of text, which doesn't actually follow any structure or formatting. And it makes it hard for a computer to kind of understand it, because computers just, they don't have the creativity and sort of intuition that we do. So it has to analyze really unstructured text, really disorganized language, not like a contract, which has specific sections and formal words. And we want to be able to take what we learn about litigation and try to get some kind of insight and knowledge from it. So the problem that I decided to focus on is one that I have done a lot of practice in, which is cases that are before something called the Patent Trial and Appeal Board. So these aren't actually like judicial cases. These aren't going to court. But what they're doing is they're going to a specialized patent court in DC. And what happens is, after I do a patent, and I try to go sue someone on it for infringing my patent, that person who I sue has the right to go to this court and say, hey, that patent is invalid. Somebody else made the invention before you did. And here's the evidence for that. Here's like another patent which discloses the same thing as your patent claims to have invented. And then they go into a specialized court proceeding that lasts for about a year. And at the end of that, you either lose your patent or you get your patent. And that was the kind of case that I wanted to analyze, in part because that's a very structured proceeding. So it's a little bit easier to analyze than complicated judicial proceedings that can go on for years and years and have a lot of twists and turns. But also, it's really high value. There's a lot of documents for it. And it's a very kind of specialized problem, because the text that's involved is both technology intensive, because patents involve technology, but it's also very legal. And so while there are other people and scientists around the world who are studying law, like legal texts, and scientists around the world studying technology texts, there isn't anybody out there right now trying to bring the two together to try to understand things for both in terms of technology and law. So this is a really important niche for that reason. So the analysis that I looked at was a specific phase of this trial where the patent court is deciding whether to actually have a trial or not. And so what happens is the person who got sued by the patent files a petition. Then 3 months later, the person who owns the patent responds to that petition with a brief. And no more than 3 months after that, the patent judges, a special set of judges who are both engineers and lawyers, renders a decision on that petition. And so there are three kinds of documents: a petition, a preliminary response, and a decision. And that all takes place over 6 months. And so the question I kind of had was, well, can I look at the text of these documents, and specifically the response and the decision, and try to predict what the outcome of this case actually was? And so, fortunately, the government offers PDFs for all of these documents online, and you can download them in bulk. And there's a proprietary tool called Docket Navigator, which you can use to cross-check and make sure you're getting the actual outcomes correct. And I utilize that as well. The problem is, and this is going to be a consistent issue in law as we move forward, everything is being stored as PDFs. Nobody uploads a Word document. Donald Trump's lawyers sometimes upload a Word document, but most people upload PDFs because they're like normal people. And the problem is PDFs, they're not uploading a PDF that you can render into text. In fact, often really bad guys we would litigate against would specifically make their PDFs impossible to render into text because they wanted to make it hard for you to copy and paste from them. So, this obviously creates a huge problem computationally because you can get errors as you try to convert the PDF into a form that the computer can understand. And in law, there's a lot of abbreviations and citations and party names. So almost everybody who publishes in this field uses a really clean text database. Like there's something that the European Court of Human Rights offers, and everyone publishes on that. But I'm not an academic in that sense. I'm like a practicing lawyer. I want something that's real. And this is ultimately the direction we have to go in if we want to do something real. So like I said, there's a pretty PDF with beautiful text, and then it renders like this when you try to do it in text. And so this is like a table of contents, and somehow you have to teach a computer how to recognize that this is a table of contents. So that's like an initial task that you have to figure out. And then even once you get through screening out things like the table of contents, you have to figure out how do I analyze all of this stuff? There's abbreviations, there's weird quote marks, there's the name of people. So one of the problems a lot of people have is when you try to train these systems, they say, oh, well, this case always loses, this case always wins. The reason is Versada, who happens to be someone in this case, they always lose, almost always lose. So all I need to do to teach a computer for who's a loser is to pick up the word Versada, because anytime anybody, Versada files something, they lose. So, there's issues like that you have to deal with. And I'm sorry I'm moving pretty fast, but I realize we don't have a lot of time. And I kind of want to more set up the problem here. One of the other big challenges when we do law is law changes over time. Because judges change their mind about things, Congress passes new laws, and the Supreme Court makes new decisions. So to give you a concrete example of this, at the very beginning, a petition could either be granted or denied, or granted in part, which is like a mixed decision. And if you look at this graph shows the number of petitions that were either granted, in other words, the petitioner won, or denied, in other words, the patent owner won, or were a mixed decision. And if you notice, from 2017 to 2018, the number of mixed decisions goes to 0. Well, that's weird. Well, the reason is the Supreme Court, in a decision called SAS, decided in early 2018 to get rid of mixed decisions. They said, oh, the patent office has been interpreting the law wrong. In fact, there's no such thing as a mixed decision under statute. Don't do that anymore. So, okay, law suddenly changed. And so now if I have a model that's looking at these mixed decisions, it's now completely obsolete at this point. Another thing that changed is, for a while under the Trump administration, patentees got a big advantage. In other words, the people who own patents got a big advantage through a decision called fintive. And with that, I won't bother getting into legal technicalities of why, but basically that put a huge thumb on the scale for patentees. And it gave them a set of arguments that they could use that didn't exist before. As a result of that, now if I have a model of how the law works before that decision, it's no longer valid after that decision, or needs to be adjusted or added to after that decision. And then to make things more complicated, earlier this year, the new head of the patent office scaled that back because she's more modern on these issues. And so again, things change over time. So we wanted to analyze this problem. We created 2 different models to analyze it. One was a deep learning model, which I'll just throw this up on the screen to say that it looks really, really complicated, but it's not actually that complicated. But we created a kind of model where we learn features using deep learning and then interpret them using something called attention. And if you're computationally inclined, I can get into this in detail later. We also used another method in which we just looked at the frequency of words. So we did the pre-processing. This is not deep learning, but machine learning, and used a method called XGBoost to try to predict, again, the outcome of a decision, but based on the frequency of words that you find in the different litigation documents. So here are the results, and we used some different metrics to look at the results. We were interested both in accuracy, raw accuracy, as well as how well am I doing with true positives, and how well am I doing with actually identifying the correct stuff, not just am I being really accurate. So it turned out that on the one hand, I was very, very accurate. The model was very, very accurate at predicting whether someone won or lost on the basis of the judge's decision. If you think about it, this makes sense, because when the judge decides a case, they're going to have some language in there that will tell you whether you won or lost. And whether I'm specifically looking for that language or not, it'll be there. Now, every judge has a different way of saying you won or lost. They have a different way of structuring their arguments, and the model is picking up on that. But it's still able to make a relatively accurate over 80% or over 90% prediction. The blue bar represents the machine learning method. The purple bar represents the deep learning method. The yellow bar is something called logistic regression, which is a very basic kind of machine learning and was used as kind of a benchmark. And what you see is that the deep learning was actually pretty much on par with the machine learning. The machine learning did do somewhat better, but if you look at the y-axis here, it's not doing that much better on other than this particular metric. And in fact, deep learning beats it on that one. Now, the thing that we thought would be really cool is, can we actually predict the result from the brief that the patent owner writes? So here, this is just the thing that the opposition wrote. This isn't something that the judge wrote. And it turned out that we could actually predict over 50% of the time, no matter whether the decision was a win or a loss, from the brief that the patent owner wrote specifically, whether there was a win or a loss. In other words, we could pick up on things in the opponent's brief that was either a winning or losing argument. And in that case, deep learning and again, machine learning were roughly on par, but deep learning did beat machine learning on a number of metrics. So then we looked at some interpretation methods, and we were able to see, using our interpretation methods, this is a method called SHAP, which we use on one of our methods. And we learned that, for example, when you look at a judge's decision, if they refer to the stage of the proceeding, they're often denying, or they're often granting the petition. And what they're basically saying in that case is they're saying, at this stage, I'm going to let you move forward to trial. That doesn't mean that I'm deciding the case, but at this stage, you're good enough for a win, for this kind of a preliminary win. So when you see the word stage, that means the judge is probably going to give the petitioner a win. When you see the word purposes, often that's a loss for the petitioner. Sometimes it's a win, but the context there matters, because often what you're saying there is, for the purposes of this proceeding, I'm going to give you a win, but it's not really a win in total. So the model is able to pick up on keywords like that and kind of infer from that what the judge decided. Using deep learning, we can actually highlight the text and identify key words and phrases at different levels of resolution that were influential in the model making its prediction. And again, this was just something that validated to us that whether we're using deep learning, which is the two columns on the left, or machine learning, which is the two columns on the right, we're actually able to get relatively similar results when we go to interpretation. And this example shows that we're actually able to pick up on successful kinds of arguments. So for example, in the first case, somebody's talking about how awesome their worldwide cellular network is, but they lost the case. The patent owner in this case lost the case, the petition was granted. And the reason for that is when you talk about things like cellular networks, the model is picking up on the fact that often cellular network patents are losers. In the second example, the patent owner raised arguments that are really compelling about how there's parallel litigation, how if you do this proceeding at the patent court, it will delay everything. Please deny the petition. And as I was saying, during a few years, this kind of argument was often very successful. And the model is picking up by highlighting in green the really successful argument that was being made. So that was sort of a preliminary indication that we were on the right track. Now we're moving forward, or I'm moving forward with looking at a broader kind of model, which will take in, again, a lot of this kind of language that weaves together technology and law, but from a lot of different kinds of cases that involve technology and law, and pulling all of that stuff together to try to create a bigger and more useful model that, again, combines technical terms and legal terms. This is something that no one else is doing. Everyone is either doing legal terms specifically or technical terms specifically, or just general language. But the problem is when I have a model for general language, it does very poorly when you get to specialized text. And so we do need to create these kinds of more specialized models for specialized problems. So thank you very much for your time. Thank you very much to the Drexel Libraries for supporting the publication of this work, which, while it is tangentially funded through Professor Rosen's work, is really not fully linked to it. And so a fund like this helps support this kind of exploratory research that isn't necessarily part of a funded project, but is something that is interesting, should get out there. And this lets it get out there through open access publications. And so we really appreciate this fund and hope that it moves forward, because it really does help with projects like this that kind of would otherwise fall through the cracks or have to go to a much more obscure journal that charges a subscription fee and no one would ever read it. So thank you very much.
Thank you for your talk. And we are at time, so people are welcome to leave. If Bahrad would like to stick around for a few minutes for questions that people have,
we're happy to leave a few minutes. Yeah.
So we're happy to leave the chat open. There's no questions over chat, okay. But if somebody has a question, you're welcome to take it. But if you have to go, feel free to head out. Thanks for your time.
No, thanks all. If you have any questions, you can ask me. If you're in our group, please feel free to ask me questions, obviously, because we all talk to each other about stuff. I know that for our group, I usually talk about biology. So this was an opportunity to talk about the mysterious other stuff that I'm doing.
I just want to add a comment and a small question, quick question. Excellent presentation, Bahrad. And my name is Jai. I'm the engineering librarian here at Drexel Libraries. And my question is, I'm really fascinated by deep learning and your machine learning approaches that you used. So I was wondering if that can be used to predict possibility of next pandemic, or could be something about different variants that could happen using these approaches.
So this is really interesting. So actually, I wish I had thought of doing this. There is a paper that I saw recently where somebody's using a deep learning text model. So the model that I'm using is adapted from something that's called sentiment analysis. So people were really interested in, like, if I have a tweet or if I have a social media post, is it hateful? Is it happy? Is it, whatever? Companies are interested in this for like comments for products, where they're like, is this person's comment positive or negative? And so they created this kind of deep learning architecture for that. And I took that architecture, which has been around now for several years, and bolted on this attention layer for interpretation. Anyway, so as a preface, what I'm doing is not that novel on that side. So somebody took that kind of a deep learning method, I'm not sure what architecture they used, and they applied it to looking at social media and stuff to try to see if they could predict like a variant coming up, or kind of a spike in cases. And I think they showed that they were relatively successful in doing that. So yeah, I mean, I'm focusing now, obviously there's a lot of biological stuff you could apply deep learning to as well. That's kind of outside the scope of what I talked about. But even just looking at text, yeah, I mean, people will say things like, oh, I have a stuffy, I have COVID, or I tested positive, or I have a stuffy nose, or I can't smell. And people can pick up from that. If I scan enough messages, I can start to see a spike before I might necessarily see it in case counts. So yeah, people are looking at that question anytime you have text.
Great, thank you.
Okay, great. All right, well, thank you, everyone. And yeah, let me know. Please feel free to contact me, email me if you have any questions, or talk to me later. All right.
Hey, Bart, I have a question.
Okay, go ahead.
Yeah, during your talk, you mentioned like choosing a judge based on the analysis of AI. And I'm not so familiar with the like judicial processes, but are there like any like ethical problems with that, like choosing a judge that would be more favorable for your trial?
So there's no, in short, no. I mean, you're just looking out for your client, right? I mean, it's unethical if like when I was on a federal circuit, there was a judge who wrote about one of the lawyers who appeared before him. You were like the best person who I've ever seen argue before us. Please feel free to show this to your clients. Come before us anytime you want. Your friend for life, Randy Rader, or whatever he chooses to call himself. So this was the chief judge of the federal circuit. It turned out there was an ethical problem with doing that because he was forced to retire and in disgrace. So that's bad. So if a judge actually goes to you and says, I will look favorably on your case, that's bad. If a judge comes and says, I will generally try to make these cases go faster, that's totally fine if he does that in a public forum to everyone. And you don't need AI for that. Everybody knows who that judge is. And everybody used to file their cases in Waco before they, you probably heard of like the East, it's like courts in Texas, right? Everyone knows a court in Texas is favorable. But what we're looking at here instead is just looking at patterns of how a judge makes decisions and then going to that judge. There's no insider information. And so in that case, there's no ethical issue. We're just observing what's happening in the world and what the judge is doing. So as long as there's no direct kind of communication or direct payoff, it's totally fine. But there is some randomness. So sometimes you can go to a district and get the wrong judge or something. So sometimes you're playing the odds, and I don't need to get into the different things you can do with that. But there's a whole art to this stuff. But yeah, it's not unethical. Using AI in law is not generally unethical, unless you run into these bias issues. There is some ethical issue. For example, there is an emerging issue where people are like, well, if AI is making a decision, are they really accountable to the client? That's going to be something that emerges in the future. So do you need a human to actually be accountable for advice? Like if an NDA that a computer generates goes wrong, who do you sue for malpractice?
Yeah, that's an interesting question. Are there any like cases where like the AI decided on a case and then someone tried to sue it or its creator?
No, the closest that comes is in these privilege searches. So sometimes people use AI often in big cases, if you try to say like, you produce documents, you're probably all familiar with the idea of attorney-client privilege. So if an attorney tells a client something, it has to be kept secret. So in a big case, you have millions of emails and some fraction of those are privileged. So you use AI to try to screen out the privileged cases. And there have been disputes involving like, oh, hey, like the AI messed up. But usually parties, there's now a set of rules in place that say, everybody agrees that AI is okay. And then everybody kind of agrees on the rules that the AI will use to determine privilege. And so if there are any problems, it sort of gets sorted out because everybody's agreed beforehand. That's the closest people have come. But I assume this will start coming up in the future because, like I said, people are doing contracts using AI, but usually a lawyer is vetting it. The problem is you're relying on the lawyer not to be sloppy, and you're still paying them. So right now it's all sort of background. There's still a lawyer who you can target.
Thank you.
Yeah. All right. Anything else? Great.
if there's no additional questions, thank you again for taking the time to talk to us, Bahrad, and thank you everyone who's attended. We have 2 more talks open access week talks this week that we'd be happy for folks to join in on if you want to try to register. And thank you all for attending.